Hello students, it's Mr. B again. Today we are going to learn a new skill called balancing chemical equations. This is one of the more challenging things I think we'll be doing, at least that we've done up to this point in the school year. But it's a really great skill to learn, and it's something you're going to be doing in high school and college as well. And I think it'll help with math as well, which is great. It's going to help in a lot of ways. Okay. So first, let me show you a chemical equation. This is an equation. You've seen me write them on the board before, and let's go through the different parts of the equation. Okay. So a chemical equation is just a way to show that a reaction is happening. Do you remember, a reaction means that a new substance is formed. Chemistry has happened. Okay. So we're in this specific reaction, we're taking sodium, which the symbol for sodium is Na, as you can see right here. We're taking chlorine. The symbol for chlorine is Cl. And then we're doing a reaction. This arrow right here means that we're doing a chemical reaction. So whenever you see an arrow, that means a reaction has happened. And then it's turning into NaCl. Sodium chloride is the name of that. It's also known as salt, the kind of salt that you put on your dinner, that's in soup, that you put on popcorn. This salt is the stuff that we eat, and it's made from sodium and chlorine, which interestingly enough, on their own are both poisonous. But when you put them together to form salt, they are delicious and good for you. Okay, so this equation looks great. It's showing that sodium and chlorine can go together to form salt, but there's something that's incorrect about it, I guess you could say. And I'm going to show you what that is. So if we look at right here, we have a sodium atom right here. Now my question for you is, how many sodium atoms are on this side of the equation? So it just says Na, just the chemical symbol for sodium, but there's no subscript here. The subscript is where you can see how many atoms there are. If there's no subscript, that just means it's a pretend 1. Okay, that's a really terrible one. I'll draw a better one for you. So that means there's one sodium atom on this side. So there's one sodium atom. Here we have a subscript of 2 on the chlorine. So that means there's 2 chlorine atoms. But over here on this side of the equation, we only have 1 sodium atom and 1 chlorine atom. So what happened? There's not the same number of chlorines on both sides. Did a chlorine just magically disappear? Like, chlorines can't just magically disappear. We have to figure out where we're getting this extra, or where this chlorine molecule is going, this chlorine atom. So we have to do something that's called balancing the equation, which means we have to figure out how much sodium and how many chlorine molecules actually, I'm just going to erase this and draw it again, actually reacted to form sodium chloride, okay? Put that 2 back. Okay, so let's do that again. So we have 1 sodium, 2 chlorines, 1 sodium, 1 chlorine, okay? So these are imbalanced. So the only thing that you can change to make this equation go into balance is you can change this number right here, okay? So this number is called the coefficient. You're going to learn about this in math as well. But this coefficient, there's nothing written right here. So when there's nothing written, what number is it? It's number 1, okay? So you can kind of think of it as 1 sodium, 1 chlorine, and 1 sodium chloride together. But we can change this number as scientists trying to balance the equation. We can change it to other numbers, okay? Like if we wrote that we thought 2 sodium atoms reacted, then it would be 2 times 1, because it's 2 of these molecules, which is just 1 sodium. So 2 times 1, that changes that to 2 sodiums. Now we have 2 sodiums, 2 chlorines, and then 1 sodium and 1 chlorine, okay? Now remember, these don't have anything written here, so what number is there? Is it supposed to be there? It's supposed to be number 1, okay? So these are 1s as well. So we have 2 sodiums and 2 chlorines, and on this side we have 1 sodium and 1 chlorine. Is there a number you think that we can put in this spot to make it balanced, to make it so it's 2, 2, 2, 2? If you're thinking the same thing as me, then you are probably thinking we can put a number 2 there, okay? So with the number 2 there, we can get rid of these 1s, and 2 times 1 is 2. 2 times 1 is 2. Okay. Now we have 2 sodiums, 2 chlorines, 2 sodiums, 2 chlorines. Okay. So in reality, what's happening when this reaction occurs, it isn't that 1 sodium atom and 1 molecule of 2 chlorines are reacting. It's that 2 sodium atoms and 1 chlorine molecule are reacting to form 2 sodium chloride molecules. This is how this actually happens in real life. Okay. So the whole point of this is we're trying to manipulate, we're trying to change the coefficients, the number in front of our different reactants for the chemical equation so that all of these will balance on both sides. Okay, so that's one example. Let me do another one for you. Okay, I pulled one up on my computer, so let me find it again. Okay, this one is going to be a little bit weirder for you. Okay, so it's going to be P plus O2. Remember that oxygen always forms a molecule with 2 oxygen atoms. Goes through a chemical reaction to form this P. Oops, let me draw a little. I guess changing everything here. A line there. It's P4. O6. Okay, I don't know what this is called. Phosphoxide or something. I'm not sure. Anyways, okay, so now the first step when we're solving these is always to figure out how many atoms we have of each element before we get started. So this P right here, there's nothing written here, and there's no subscript, so we know that it's a 1 and it's a 1. So 1 times 1 is what? It's 1. So we can write a 1 there. That's how many phosphorus we have on this side. We have nothing written in front of the oxygen, but we have a 2 here. So it's a 1 times 2, which is what? 2. Okay. Then we have nothing written here, so we know it's a 1. And then this is a 4 and this is a 6. So 1 times 4 is 4. And then 1 times 6 is 6. Okay. So we got a major balance problem here. We got 1 phosphorus, 2 oxygen, and then 4 phosphorus and 6 oxygen. Okay, so we're gonna have to figure out how we can balance this thing. So let me erase these right here. Okay. So let's figure this out. So I'm thinking that an easy way to get 2 oxygen atoms to turn into 6 oxygens over here is to multiply, is to figure out what I can multiply 2 by to get 6. I know that 3 times 2 is 6, so I can put a 3 here. 3 times 2 is 6, so let's change this number down here. Okay, oops, forgot to add it back. So this is 6 now, these two match, which is great. Now, all I need to do is change it so I can get to 4 phosphorus, and the convenient thing is that this phosphorus is just 1 right here. So I know that if I'm trying to change this to 4, and the only thing I can change is the coefficient right here. What do I have to multiply 1 by to get to 4? And that answer is 4. So let me, oops, keep doing that. Put a 4 here. 4 times 1 is 4. Now it matches. We have 4 and 4. So all I need to do on that one was put a 4 in front of the phosphorus, 3 in front of the oxygen, and now it matches. This stays 1 right here. You can write a 1 there if you want. And we have 4 phosphorus and 6 oxygen on this side. Okay. Now I think I'm going to do one more just for fun to help you guys. Wasn't originally planning on doing one more, but that's okay. I feel like this will be challenging for some students, so we're going to give one more example here. Okay, here's a good one. So it's going to be H2. This might actually be in your worksheet as well, but that's okay. Plus O2 reacts to form H2O. Okay. We've actually done this reaction in our class. This when we burned our hydrogen gas from the batteries. This is what reaction was happening. We were turning hydrogen gas into water. Okay. So let's go through and find out how many atoms we first have on each side. So there's no coefficients in any of these, so that means it's just a 1. So 1 times 2 is 2 hydrogen atoms. 1 times 2 is 2 oxygen atoms. 1 times 2 hydrogen here is 2 hydrogen atoms. Then 1 times 1, because there's nothing written here, so it's a 1, is 1 oxygen atom. So all of these match except for the oxygen, which we have 2 on this side and 1 on this side. Okay? So I know that this isn't going to get any smaller. I can't get 1/2 here to make it 1. That's not going to happen. So, oh, by the way, you can't have fractions or anything in these. That's not allowed. You can only have whole numbers. So I know that in order to get this to match, I'm going to have to put a 2 here. Okay? So 2 times this 1 changes this to 2. And then 2 times the 2 hydrogens changes this to a 4. Okay? So now we have 4 hydrogens and 2 oxygens. The oxygens match on both sides, but the hydrogen doesn't match. Okay? Because this hydrogen is 2 over here. So what can we do to get this hydrogen to become 4? Well, we know that it's 2 hydrogens per molecule. And what can I multiply 2 by to get 4? Well, the answer is 2. So I'm going to put a 2 here. So that changes this to a 4. And now it matches. 4 on this side, 4 on this side, 2 on this side, 2 on this side. Okay? So 2 hydrogen molecules plus 1 oxygen molecule equals 2 water molecules. So this is the reaction that was actually happening when we did our blowing up the gas in our class. Okay? So this brings me to an interesting point, which is also very important for us to understand. So here's my question for you. Was there ever a time in here where an atom randomly popped into existence or just disappeared completely? Was there ever a time when an atom was there but then was gone, or we needed an extra hydrogen so it just popped out of nowhere? No. There was never a time when that happened. So this is something called, I'll see if I can write it the best I can here, the law of conservation of matter. Okay? So what this says, the law of conservation of matter, is that atoms cannot appear out of nowhere, they can't be created, and they can't be destroyed. Okay? So all matter is that we have already exists, and it's not going anywhere, and we can't change that. Okay? Now there are some little weird ways that like for instance, if you do nuclear fission, you can change the type of atom that you have. But again, the matter, the atoms themselves don't disappear or appear out of nowhere. They are always around. They're not going to go out of existence. Okay? So what that's trying to say is that atoms, you can never create or destroy them. That's probably the easiest way of saying it. They cannot be created or destroyed. Okay. There's a part in your project that asks about this. I can't remember exactly the phrase, the way that I said it, but it asks you if any of the atoms when you were balancing your equations got created or destroyed, and the answer to that is no. Atoms are always around, and they're going to stay there forever. Even if they change form, even if the chemistry changes, the atoms themselves stay forever. Okay? And I might create a separate video about the law of conservation of matter if this gets really confusing for some kids. But here's a good intro for you that should teach you how it works. Okay, I think that's all we need to know for now. Yeah, good luck. I'll be here to help you with balancing your equations.